So when you go through the algebra, ultimately you'll be able to show that the log of the relative price of non-traded to traded goods, that's log of Q, is a function of total factor productivity in the traded goods sector minus TFP in the non-traded goods sector plus some function of the world real interest rate. Okay, so that's what we can show. Now, what is the intuition over here? Okay, so we are mainly interested on what impact technological change is going to have on Q. So what we are saying is, well, technological progress generally tends to be concentrated in the traded goods sector. So we expect AT to generally grow at a much faster rate than AN. And suppose AN does not change and AT goes up, that is going to increase the relative price of non-traded to traded goods. Okay? That is the essence of this Balassa-Samuelson hypothesis. Okay? So, of course, when we implement this empirically, we have to be careful about the unit root properties and co-integration, etc. But that's the intuition. Okay, so TFP tends to grow faster in this sector, and as AT grows faster compared to AN, we expect Q to go up as well. Okay, and so as Q goes up, that will appreciate the real exchange rate of the country. Okay, so that's the underlying idea. So now let's think how we can implement this model empirically. So first assumption we're going to make is these two technology processes, AT and AN, they are different stationary, or I1, possibly with non-zero drift. So technology follows a unit root process. Again, this is something you can test. This assumption is testable. We actually test it. Second assumption is log AT and log AN are not co-integrated with each other. Okay? Again, if they are co-integrated with each other, their unit roots would cancel out, and then relative price would not have a unit root, and then real exchange rate would not have a unit root either. Okay? So what we are saying is that basically if log AT and log AN are not co-integrated, it means that technological progress in the traded goods sector does not get transmitted to the non-traded goods sector, even in the long run. Okay? So the two sectors are really different from each other in a fundamental way. Okay? Just because technology is improving in the manufacturing or tradable sector doesn't mean that that improvement in technology will also apply to the non-traded goods sector. Okay? So that's the second assumption. The third assumption is this log of the world real interest rate is a stationary or I0 process. Okay? So what is the justification for these assumptions? Well, the third one is just to make our life easy. Okay, it's hard to measure the world real interest rate, right? So for a single country, you may be able to measure what interest rate is for the world. You take each individual country's nominal rate, then you take a weighted average for all the countries in the world, and you do the same thing for inflation. You subtract that, and that's just too much work and painful. So if you assume it is stationary and you can just throw it out, it's not going to affect. We know that in a co-integrating regression, anything that is stationary, if you leave it out, that does not affect anything. Okay? So when it's difficult to measure something, and in this paper, the focus is not on the real interest rate, focus is on the technology part. So we just abstract from this, assume this is stationary. Okay? in fact, many macro models also imply the real the real interest rate to be stationary. Right? It's in macro models. This is related to the growth rate of consumption. Right? From the first order conditions, the real interest rate equals the growth rate of consumption, and so the growth rate of consumption cannot be non-stationary. Okay? Consumption can be non-stationary, but not its growth rate. Okay, so here is the justification for these assumptions. So first assumption simply is a necessary condition for technology to explain the unit root in the relative price. Right? If technology does not have a unit root, it cannot explain why relative prices have a unit root. Second assumption tells us that technological progress is not transmitted from one sector to the other, even in the long run. So these, the unit roots in AT and AN will not offset each other. Okay? And we're going to look at the assumption for these two, we're going to look at the evidence for these two assumptions. And then the third assumption, we maintain it for two reasons. First, many economic models predict the real interest rate to be stationary. And second, difficult to construct an accurate proxy for the world real interest rate. Okay, so taken together, what do these three assumptions tell us? Well, they tell us that log of Q, the relative price of non-tradable to tradable goods, should be unit root non-stationary, and it should be co-integrated with the labor share adjusted TFP differential. So log of Q should be co-integrated with this. Okay? So this is a typo. It should be alpha n over alpha t over here, and nothing over here, minus log an, so this part. This part is stationary, so this should be co-integrated with this. Okay. So please make the correction over here. So we define Qm to be this part. Alpha n, maybe I should write this down. Okay, so this is the value of Q predicted by the Balassa-Samuelson model. So M is for model. So the model says Q should equal this. So what we will test, so we do a regression like this. Mu plus gamma Qm plus some error term, and then we want to test that this error term is I0, this error term is stationary. That means Q is co-integrated with this TFP differential in the traded and non-traded goods sectors, and gamma should equal 1. The coefficient gamma should equal 1. Okay, so these are the two testable predictions of this model. So basically we are saying the relative price of non-traded goods should be co-integrated with the TFP differential in the tradable and non-tradable sectors with a coefficient equal to 1. Okay? Is it clear? Any question? Is it okay? Okay, so So now we're going to do this in two ways. First, we do it with a single equation method, so single equation unit root, single equation cointegration test, and then we do it with panel unit root and panel cointegration. Okay? So let me skip the econometric methodology. I'll say a few words about data. Okay, so we use industry level data. Okay, so we have different industries, and we are going to combine them into tradable and non-tradable. Okay, so there are many different industries in any economy. Some of them produce tradable output. Some of them produce non-tradable services. So agriculture, manufacturing, mining, and retail and transportation, we classify as traded goods. Utilities like electricity, gas, and water, financial services, insurance, real estate, private and government services, we classify them as non-traded goods. Okay, so we use industry level data and then combine them into a traded good and a non-traded good. Then we have to estimate the technology coefficients in each sector, in the tradable and non-tradable sector. So that we construct as a solo residual from constant price domestic currency series, because we have data on output, capital, labor share, and employment. So you can back out the TFP. You know how to do that, right? Maybe I'll. It's a standard kind of thing. Okay, so we have data on output, right? Because we combine different industries into the traded industry. We have output for this in constant prices. We observe employment in the traded sector. Again, it's by combining each industry's employment. We have capital stock in each industry. Again, when we combine, we get capital stock for the traded industry. Okay? Alpha is the share of labor, right? And that's something we don't always observe. So alpha is a parameter and it could be unknown, but under perfect competition, alpha is the share of compensation that goes to labor. Okay, so basic macro, you may have learned something like that. So alpha can also be interpreted as the share of output which goes to labor as compensation for labor services in production. And 1 minus alpha, therefore, is the share of output that goes to non-tradables. So we observe, we can get the value of alpha from there. Okay? So then we know everything in this equation except AT. So you can back out what AT is. Okay? So you can estimate technology in traded and non-traded industries like that. Okay, so properties of the data. So these are unit root tests for TFPs and relative prices. So here we have data for 14 countries. For each country, we are testing whether technology has a unit root in the traded sector, in the non-traded sector, and log of the relative price of non-tradables, whether that has a unit root. And generally speaking, we cannot reject the null hypothesis of a unit root in any of these. So all of them have a unit root. Then the next thing we look at is is whether the TFPs in the two sectors, are they co-integrated with each other? Okay, so we mentioned if AT and AN are co-integrated with each other, they will cancel the stochastic trend, and then relative price cannot have a unit root. So here we see, are they really co-integrated with each other? And we cannot find any evidence of co-integration. So this is the null hypothesis of no co-integration, and we cannot reject it. And you can see with one or two exceptions, we generally don't reject that. So that means TFP is evolving differently in the traded and non-traded goods sectors. They are not co-integrated with each other. And then next, we test the main result. Okay. Now the main thing we are interested is in co-integration between the relative price of non-traded goods and the TFP differential in the traded and non-traded goods sectors. Right? So that's QM, the TFP differential. So here we are testing for co-integration country by country, one country at a time, single equation. And the theory predicts that they should be co-integrated, and this coefficient gamma should be 1. Okay, so what do we find? Well, gamma seems to be all over the place. You can see it's 3 over here, 2, 1.4. Or some of the countries it may be close to 1, like Japan, Netherlands, Sweden. Okay, but for many of them it's jumping around quite a bit. It's not always close to the predicted value. Here we are testing the null hypothesis of co-integration. Okay, and it's accepted in many cases, but sometimes you can see here it is being rejected. Okay, so when we look at the single equation methods, then the results are not so strong for the Balassa-Samuelson hypothesis. Okay, so you can read the paper. Okay, so there is a large cross-section variation in the value of gamma from a high of 3.25, but if you look at and the low value is 0.16, so large variation. Okay, here we look at the evidence for co-integration, and again, it's not perfect, so it's kind of mixed. You can read the details here. So to get better results, what we now want to do is look at more powerful panel co-integration tests. Okay, so we look at some panel co-integration tests here. These are Cow's and Pedroni's tests. These are generalizations of the Dickey-Fuller and augmented Dickey-Fuller test to a panel case. Okay, when we use these, you see that we can easily reject the null hypothesis of no co-integration. All of these you can reject; they are significant. Okay, you can reject the null hypothesis of no co-integration. Second, when you estimate the value of gamma now using panel dynamic OLS or panel weighted dynamic OLS, the value of gamma you can see is much closer to the theoretical value of 1, right? Almost indistinguishable from 1 in many ways. Okay, so using the more powerful panel co-integration tests, we find much stronger evidence in favor of this Balassa-Samuelson hypothesis. And finally, we look at panel unit root test. So panel unit root test imposes a value of 1 on the coefficient, right? So here, this is the relative price of non-tradables. This is the TFP differential implied by the model, and this is the difference between the two. So we are assuming that gamma equals 1, and we impose that here, and we construct the residual. So what we see is log of the relative price of non-tradables, that has a unit root. With the panel unit root test, we cannot reject the null of a unit root. TFP differential has a unit root, but the residual, when we look at the gap between relative price of non-tradables and the TFP differential, that does not have a unit root. We can reject the unit root over there. So that is telling us that the relative price of non-tradables is basically being determined by the TFP differential between the tradable and non-tradable goods. Okay? So to conclude, what are we saying? Okay? What we are saying is different trends in technology in the tradable and non-tradable industries, they create a unit root in the relative price of non-traded to traded goods. And that, in turn, creates a unit root in the real exchange rate. Right? Earlier, today in the first half, we saw real exchange rate is a weighted average of Q in the home country and Q in the foreign country. If Q in each country has a unit root because of different trends in technologies, then the real exchange rate will also will inherit that same unit root. Okay? So one reason why we observe very persistent deviations from PPP is because technologies evolve differently in the tradable and non-tradable industries. Okay, so that's the bottom line. I have uploaded a set of homework questions on Canvas. So quickly, let me show you. So if you go to Canvas, there is a group homework folder. So there's some questions here, and there are 2 data files that I have given you. In one of the questions asks you to test this Balassa-Samuelson model for Hong Kong. So that has this data. The other one is money demand function for the US. Okay, so you will be doing the unit root tests and co-integration tests that we have learned in eViews. Okay, so please work on this, and it's due in 3 weeks from today. So you have 3 weeks to complete it. If you have any difficulties while doing the homework, let me know about it. Okay, thank you.
他那个 let me know about it 说的好有含义。